section 4.2, factoring quadratic equations, which I think a better title for this section would be solving quadratic equations by factoring. Just a reminder that we've already looked at solving quadratic equations by graphing in 4.1, so now we're moving on to solving by factoring. What we will be taking a look at, three things: factoring a variety of quadratic expressions. For the most part, this is going to be a review of last year's factoring that you did, plus some new stuff. And then factoring to solve quadratic equations. And then we're going to solve a problem involving quadratic equations. So for the first part, this would take care of examples 1 and 2, and this would be example 3, and this would be example 4. Alright, so we're going to start with our review, and our review will mostly be example 1. And we're going to start out with some pretty basic ones, and then I'm going to ask you to take out a sheet of paper and continue on that with the second part to this example 1 video that I'm going to do, and just follow through on some more difficult questions that you did last year. Okay, as with all factoring questions, the first thing that you should be asking yourself is, do you have a GCF? Okay, remember that means greatest common factor. In other words, do you have a common factor that fits into each of your terms evenly? And of course, we're looking for the greatest one, so the biggest one that fits into each of these evenly. And the answer for this is yes. You can see that the coefficient on all three terms is divisible by 2, so we know that part of our GCF will be a 2. And then you ask yourself, well, how about the variables? So I've got x squared x, and there's no x here, so is x common to each of the terms? No. So my GCF is 2. So you're going to start by writing 2 and then a bracket. What goes inside the bracket is whatever's left over when you pull the 2 out. Okay, so remember, when you factor your GCF, you always write your answer as a product of your GCF times a factor. So how do you get that factor? Well, you take each of your terms in your original trinomial and you divide by your GCF. So 2x squared divided by 2 is x squared. Negative 2x divided by 2 is negative 1x, or x, negative x. And negative 12 divided by 2 is negative 6. So what you have inside the bracket now is a trinomial where a is 1, right? The coefficient in front of your x squared term is a 1. And when you have that situation, you will factor by inspection. Okay, so when a equals 1, factor by inspection. That's just a fancy way of saying trial and error. Okay, so what are you looking for? All right, well, first of all, you want to rewrite this because you know that your trinomial will factor into 2 binomials, so 2 and then 2 sets of brackets. So what are you looking for? You're looking for 2 numbers that multiply to give c, okay, the constant c, which in our case is negative 6, and add to give b, okay, the constant b, which in our case is negative 1. Okay, so how do you do that? Well, you need to first start by writing all your factors for negative 6. So you can have, I just want to find some room to put this. I guess over here is good. You can have like negative 3 times 2 or 3 times negative 2. You can have negative 6 times 1 or 6 times negative 1. So what you're asking yourself is, which of these products, which will give me negative 6, are going to add to give me negative 1? And the only pair that do is this one. Negative 3 times 2 gives me negative 6, and negative 3 plus 2 gives me negative 1. So we know that that one will work. Okay, so start by writing the factors of your first term, and the only way to factor x squared is as x and x, and put your x's in the front of both brackets, and then you take the two factors that you came up with, the minus 3, and write minus 3 in the first bracket, and the plus 2, write that in the second bracket, and you have now factored the expression. Okay, and just a reminder that if you want to check your answer to see if it's correct, you are going to expand to see if you get back to the original question. So I'm just going to do that on this question. And in the future, if you have time on a test or a quiz to do that, you really should. Okay, so I'm going to start by foiling. I'm going to multiply x times x, x times 2, negative 3 times x, negative 3 times 2, and not forget that I have a 2 there. So x times x is x squared, x times positive 2 is 2x, negative 3 times x is negative 3x, and negative 3 times 2 is negative 6. Combine your middle terms, and that will give you x squared minus x minus 6, and then the last thing you're going to do is expand and distribute your 2. So you're going to go 2 times x squared times negative x times negative 6, and I'll just write that here. You are going to get 2x squared minus 2x minus 6, and notice it matches your original question. Oh, sorry, this should be 12. Okay, and it matches your original question, right? Okay, so we're done on that one. All right, so B looks like it's a little trickier, and in a way it is, and that's because your A value is a fraction. So do you have a GCF? Yes, you do. And your GCF is the coefficient on your x squared in this particular case. Okay, so 1/4. So we will factor that out. So we're going to go x squared divided, sorry, 1/4 x squared divided by 1/4, which leaves me with x squared. Negative 1x divided by 1/4. Well, 1 divided by 1/4 is 1, so, sorry, 4, so you're going to go minus 4x. And negative 3 divided by 1/4 is negative 12. And notice inside the bracket you have a trinomial where your coefficient on x is a 1, so you are going to factor by inspection. Okay, so write your GCF on the outside of the bracket and write 2 sets of brackets. The only way you can factor x squared is by x and x. Place those at the front of each bracket. And then what two numbers multiply to give me negative 12 but add to give me negative 4? That would be negative 6 and positive 2. So negative 6 times 2 is negative 12, and negative 6 plus 2 is negative 4. And you have finished factoring this question. Okay, so the next question is a binomial. All right, notice the first two that we factored were trinomials. This one's a binomial. When you get a binomial and you're asked to factor, you should check to see if it's a difference of squares. Okay, so I'll write that down here for you. A difference of squares. Okay, so what that means is that you should have two perfect squares. So check to see if your first two terms are perfect squares. Is 9x squared a perfect square? Yes, it is, because when you square root it, you get 3x. Is 0.64y squared a perfect square? Yes, it is, because when you square root that, you get 0.8y. So check to see if your first and your second term are perfect squares, and then check to see if your middle term is a minus, because you want the difference of your squares. Okay, and so this is indeed a difference of squares. So how do you factor them? All right, well, leave yourself a little bit of room here. The way to factor it is you want to square root your first term, so you want to square root the 9x squared, and the square root of 9x squared is 3x, and you want to put that at the front of each bracket. And then you want to square root your 0.64y squared. Okay, and you're going to get 0.8y, so put that at the back of each bracket. And all difference of squares factor into a sum and difference. So one bracket is plus and one bracket is minus, okay? So I'm just going to make a note of that. A difference of squares factors into a sum and difference. Okay, so that concludes the first part of our review. The second part will be on your lined sheet of paper that I'm hoping you will go and get and view the second part to example 1, which I will call example 1b, okay? And this one will be called example 1a. Okay, so we're going to take a look at how to factor trinomials where a does not equal 1. And the example that I would like to take a look at is 6x squared minus 7x minus 3. Okay, so take a look. Your a is equal to 6, so not 1. So the first method that I want to take a look at with you is just a review from last year. It's called the AC method. And you can also call it decomposition. Okay, and so you should be familiar with this. Okay, so step 1, you want to find the product of AC. Okay, so according to our question here, A is 6 and C is negative 3. Okay, don't forget the sign in front of your numbers. All right, so the product then, AC is equal to 6 times negative 3, which is negative 18. Second step, you want to find two numbers that have a product of AC, okay, in our case negative 18, and a sum of B, okay, that's the letter B, in our case the letter B being negative 7. Okay, so two numbers that will multiply to give me negative 18 and add to give me negative 7. All right, well, my factors of 18 are 9 and 2, and 18 and 1, and 6 and 3. So which of those pairs of numbers could possibly give me a 7? Well, that would be the 9 and the 2. Provided, of course, that the 9 is negative and the 2 is positive. So test it out. Negative 9 times 2 is negative 18, and negative 9 plus 2 is negative 7. So we have found our two numbers. Okay, so the next step then is to rewrite the given trinomial so that the negative 7x, which is your middle term, is written as negative 9x plus 2x, okay, because that's going to give you negative 7x. Now, the order does not matter. If you want to write it as 2x plus negative 9x, that's fine. Okay, so we still keep our first term, 6x squared, and I'm going to take the negative 7x here now, and I'm going to write it using the negative 9x and the positive 2x, and I leave c the way it is, so minus 3, okay? So it's exactly the same trinomial, all right? When I simplify this, I will get back to 6x squared minus 7x minus 3. All right, and your last step is to factor by grouping. Okay, so that means that you want to take your new expression and you want to group them into groups of 2, and you want to take the GCF out of each bracket. So in our first bracket, our GCF is 3x, All right, 3 goes into 6 evenly, 3 goes into 9 evenly. It's the biggest number that goes into both of those numbers evenly, and you've got x squared and x, so you can pull an x out. So that leaves you with 2x minus 3. Now, if you take a look at what we have in this bracket now and what we have here, you'll notice that they're exactly the same. So the GCF that you want to pull out of this second bracket is just going to be plus 1. Okay, so now you're going to finish up your factoring. Okay. And my GCF is 2x minus 3, and I am left with 3x plus 1. Okay, so this 3x and this plus 1 goes into this bracket, and your 2x minus 3 goes into the first bracket. And of course, the order of the two brackets makes no difference. Okay, if you want to write it as 3x plus 1 times 2x minus 3, that is fine. Okay, so that finishes up our first method, which is a review of last year. And the method that I'm going to encourage you to learn this year, and I know that my students from last year learned this, but I'm not sure if the rest of you did. We are going to use, I'm hoping that you will, use inspection. Okay, which is just a fancy word for trial and error. Okay, by using an organizer. Okay, so my organizer is going to be a large plus sign. Okay. In the first column, because now we've got two columns, we've got this column, we've got this column. In our first column, we're going to put the factors of A, and in the second column, the factors of B. Okay, so A is 6. Now, there's two ways that I can write the 6, of course. I can write the 6 as 6 times 1, and I can write it as 3 times 2. And this is where the inspection comes in. This is where you're going to be considering trial and error, because you've got two possibilities for the 6. Oh, sorry, this should be C. Okay, and the factors of C, which is 3, is just 3 and 1. So this one is a given. There's only one way to factor the 3, so 3 and 1. So you will be using those two factors for the 3. Okay, but you can use some reasoning to decide which pair of factors you're going to use for the 6. Usually, if this middle number is smaller or comparatively the same, not exactly the same, but close to in value, your A and your C, then usually it's a good idea to choose the two factors that are closest together in value. And I know it's a guess method, but it's a good educated guess to use those two numbers as opposed to the 6 times the 1, okay? And as you become more experienced with this method, you'll know why it's better to use the 3 and the 2 in this situation, okay? So I'm going to put my 3 here and my 2 here. Okay, right now we don't really know where it's going to go, so we're just going to do a guess. And I'm going to put this 3, my C factors, my 3 and the 1, in the second column. And now we're going to cross multiply. Okay, so we're going to multiply the 2 times the 3 and the 3 times the 2. Okay, so when I go 2 times 3, I get 6, and when I go 3 times 1, I get 3. And what I want to see is, does the 6 and the 3 at all add up to -7, or can it add up to -7? And it can't. It doesn't matter what signs the 6 and the 3 have on it. It won't make a -7. So trial and error. When you get that, you're going to try again. Okay? And I'm still pretty sure that I'm going to use that 3 and the 2, so I'm going to leave that. What I'm going to do now, instead of putting the 3 and the 1 stacked in this way, I'm going to stack it 1 and 3. And I'm going to cross multiply again. And so 2 times 1 is 2, and 3 times 3 is 9. And can I get negative 7 from this? And the answer is yes. As long as my 9 is negative and my 2 is positive, I will get negative 7. So because I got the negative 9 by going 3 times 3, I'm going to make the 3 in the second column negative, because that's now going to give me my negative 9. And because I got the 2 from multiplying 2 times 1, I'm going to make this one positive and put the positive on the 1 in the second column. And now I'm ready to write my answer. Okay, I know that my trinomial is going to factor into 2 binomials. So I'm going to arrange them by grouping them in rows. Okay, so if you take a look, in the top row you've got 3 and 1, so I need to write the 3 as a 3x, and the 1 I leave as plus 1. My 2 I have to write as 2x, and I've got minus 3 for the second column, and so you can see you now have 3x plus 1 and 2x minus 3, and compare to what we got with using decomposition and the AC method. We get the same answer. Okay, now I like the second method better because it's quicker. I know it doesn't seem that way right now, but it is quicker. I'm just going to see if I can't find another example. And it's quicker because you don't end up doing all this writing. I'm just doing all this writing because I'm showing it to you. But if I was really going to do this question, I would not do all this writing. Okay, so I'm going to go through 2 more examples with you, and we will end the video after that. Okay, so here's my next example. 5m squared minus 9m minus 2. So you notice that a is not 1. I'm going to use my organizer, and I'm going to put my factors of a in the first column, my factors of c in the second column. And the only way that I can factor 5 is a 5 and a 1. So I'm going to put a 5 and a 1 here. And the only way that I can factor the 2 is by 2 and 1. So this question's actually easier because there's only one way that you can factor the 5 and one way that you can factor the 2. All right, I'm going to cross multiply. And that's going to give me 2 and 5. I want to know if that's going to give me negative 9, and it won't. Okay, so what I'm going to do then, I'm going to reverse my 2 and the 1, and I'm going to put the 2, oops, sorry, I already did that one. I'm going to put the 1 on top and the 2 on the bottom, and I'm going to cross multiply again. And this time I'm going to go 1 times 1 is 1, 5 times 2 is 10, and can that give me negative 9? Yes, it can, as long as the 10 is negative and the 1 is positive. So to get the 10, I went 5 times 2, so I'm going to make my 2 negative. And to get the 1, I went 1 times 1, so I'm going to make this 1 positive. I am now going to write my answer as a product of 2 binomials. And my first row goes in my first bracket. I write it as 5x plus 1. And my second row goes into my second bracket, and I write it as x, or 1x if you like, minus 2. Now, one way that you can check your answer to see if you're correct is you can FOIL. Okay, so you can check by foiling. So I'm going to run through that with you just quickly. So I'm going to go 5x times x, which is 5x squared. 5x times 2 is negative 10x. 1 times x is x. 1 times negative 2 is negative 2. And when I combine my middle terms, I get negative 9x, right? Negative 10 plus x is negative 9x minus 2. And does that agree with my question? Yes, it does. So I know that I have factored this correctly. Okay, my next question will be 45 s squared plus 4s minus 32. Okay, and technically I should be checking for GCFs, and I don't have one here. Okay, there's no common number that goes into each one of these evenly. Okay, so I'm going to set up my organizer. Factors of 45, there's a lot of them, right? There's 45 and 1, there's 15 and 3, there's 9 and 5. And I'm going to choose the 9 and the 5 because my middle term is a small number. Okay, so I'm going to go with the 9 and the 5, and I'll put that in my first column. And there's, once again, a lot of factors for 32, right? 32 and 1 and 16 and 2 and 8 and 4. And once again, because this is a small number, I'm going to go with my 8 and my 4. All right, and I'm going to put 8 and 4. Now, you can kind of look ahead with this, right? I mean, I'm going to put the 8 and the 4 here just because I have the same order here. But usually if I'm doing this myself, I actually think about this. Like, do I really want to put the 8 here, and do I really want to put the 4 here? I know that I'm going to be cross-multiplying. So I can do this in my head. 5 times 8 is 40, and 9 times 4 is 36. So if I have 40 and 36, can I get a 4? And the answer is yes. Okay. So I know it's going to be 8 and 4 like this, but what if you first went 4 and 8? Well, you can kind of do it in your head again. You go 9 times 8 is 72, and 5 times 4 is 20, and can 72 and 20 give you a 4? And the answer is no. So my first guess was right. So cross multiply, 5 times 8 is 40, 9 times 4 is 36. Can that give me a positive 4? Yes, it can, as long as my 40 is plus and my 36 is negative. And so to remember, to get the 40, I went 5 times 8. So that makes this 8 positive. And to get the 36, I went 9 times 4. So I'm going to make this 4 negative. And once again, top row goes into one bracket, bottom row goes into one bracket. And you will have 9s plus 8 and 5s minus 4. And you are finished. And once again, you can check your answer by foiling to see if you can arrive back at the original question. Okay, so this concludes factoring. In our next example, we're going to continue factoring polynomials in the quadratic form, and the difference this time is that we're going to use what's called a dummy variable, and I will explain what that is as we go along. So some of this will be new and some of it won't be. You already know how to factor trinomials and difference of squares. What's going to be new is using the dummy variable. So let's take a look at the question A that we have. We've got 12 times x plus 2 squared plus 24 times x plus 2 plus 9. It looks rather complicated. You could start, if you like, by expanding your x plus 2 by foiling, and then distributing your x plus 2 by the 24, and then combining all of your like terms, arriving at a trinomial, and then factoring the trinomial. But that might not be the best way to do it. So what I'm going to suggest to you is that we use a dummy variable. Notice that instead of having 12x squared, you've got 12 times x plus 2 squared. Instead of having 24x, you've got 24 times x plus 2. So in place of a single variable, you have a binomial. So what I'm going to suggest to you is that you replace your x plus 2's with another variable. Don't use the x because the question has x in it. So choose another variable besides x. I'm going to use m. And I'm going to let m be x plus 2. And in my first step, I am going to substitute in m for x plus 2. So first step, substitute m in for x plus 2. So that's going to give me 12 m squared plus 24m plus 9. So you're familiar with this. You should know how to factor that. First thing you're going to ask yourself, do you have a GCF? Yes, you do. It is not 2, it's 3. So factor the 3 out. Remember to write your next step as a product of the GCF and whatever factor is left over. And when you factor the 3 out, you will be left with 4m squared plus 8m plus 3. And second step, you're going to factor the trinomial. I'm going to use inspection. Okay, if you want to use decomposition, you can. So I know that when I factor this, I am going to have 3 times 2 sets of brackets. I'm going to set up my organizer here. My factors of 4 can be 4 and 1 and 2 and 2, and my factors of 3 can be 3 and 1. So the 3 and the 1 is given. There's only one way you can factor 3. But you have to make a decision between the 4 and the 1 and the 2 and the 2, and this is where your trial and error is going to come in. I'm going to choose the 2 and the 2. My 8's still not a really big number, so I'm going to pick my factors that are closest together in value. So I'm going to put a 2 and a 2. I'm going to cross multiply. And 2 times 3 is 6, and 2 times 1 is 2. And I need this to add up to 8. Will it add up to 8? Yes, it will, provided they are both positive, because I want a positive 8. So that means that my 3 will be positive, right? Because 2 times 3 will give me 6. And my 1 will be positive. 2 times 1 will give me 2. Just a reminder that the first row goes into the first bracket, or the second, it doesn't matter. And the second row will go into the second bracket, okay? So I'm going to write 2m plus 3 and 2m plus 1. And your fourth step is to substitute now. You're going to now replace your m's with x plus 2. So you're going to put the x plus 2 back in. So you're going to substitute m with x plus 2. Okay, so here are your m's and here's your x plus 2. So you're going to replace them. So go back to do opposite what you did in the beginning. In the beginning you took your x plus 2 and replaced it with m. Now you're going to take your m and put the x plus 2's back in. Okay, because we factored as much as we can now. Okay, so 3, I'm going to use a square bracket. Because I'm going to replace my round brackets here with square ones, and that's because I have to show multiplication when I substitute my x plus 2 back into my 2. So I'm going to go 2 round bracket x plus 2, so I've replaced m with x plus 2. And in my second bracket, do the same thing, replace m with x plus 2. And now you're going to simplify by using BEDMAS. Okay, in other words, order of operations. So I will start inside both square brackets, and I'm going to distribute the 2 over the x plus 2. And I can now change my square brackets back to round, because once I distribute, these round brackets will disappear. So I'm going to get 2x plus 4 plus 3 in my first bracket, and 2x plus 4 plus 1 in my second bracket. I'm going to combine what's inside each of my brackets. So in the first one, I get 2x plus 4 plus 3 is 7. And in the second bracket, I'm going to go 2x plus 4 plus 1, which is 5, so 2x plus 5. And you have finished factoring. Okay, and once again, if you want to check, you can FOIL your 2x plus 7 times your 2x plus 5, multiply it out by 3. You should get, oh, you wouldn't, it'd be harder to check this one, wouldn't it? Because you would actually have to expand your x plus 2 squared and distribute your 24 through your x plus 2, and then simplify everything and see if that equals what you have here. So it's a lot more difficult to check on this one. Okay, our next question. Now you notice that we have inside our brackets 2 different binomials. Okay? So what we want to do now is use two dummy variables. And let's make this one, no, that's right. Okay, so two different variables. So don't use t, don't use x, use something else. Once again, I'm going to use m, and I'm going to let m be the 2t plus 1, and I'm going to use n. So I'm going to let n be the x minus 2. Okay, so that's going to give me 9m squared minus 4n squared. So at your first step, you are going to sub m in for 2t plus 1 and n in for x minus 2. Okay, and what you should recognize now is that you have a difference of squares, so you're going to factor the difference of squares. Okay, so two brackets, or two sets of brackets, square root your 9m squared, that gives you 3m. Put that at the front of each bracket, square root your 4n squared, that gives you 2n. And remember, one bracket is plus, one bracket is minus. Okay, and our next step is to sub 2t plus 1 in for m and x minus 2 for n. Okay, so I'm going to use square brackets again. So square brackets, 3 times 2t plus 1, right, small because there's not a lot of room, 2 times x minus 2 second, I am running out of room. Okay, so 3 times 2t plus 1 and minus 2 times x minus 2. Alright, so I'll highlight that. Hopefully it'll stick out a little bit better. Okay, so that's what we are going to now simplify. Okay, and once again, order of operations. Okay, so inside both brackets, you will distribute your 3, and you will distribute the 2's. Okay, you can switch back to round brackets. 3 times 2t, 6t, 3 times 1, 3, plus 2 times x, 2x, 2 times negative 2, negative 4, close the bracket, open up your second bracket. 3 times 2t is 6t, 3 times 1 is 3. This time it's minus 2, so minus 2 times x, negative 2x, minus 2 times negative 4, positive 4. And now combine your like terms inside each bracket. So you will have 6t. Okay, and you can add your 3 plus negative 4 to get negative 1, but I'm first going to put my 2x down, and then 3 minus 4 is negative 1. Okay, I'm going to put my variable terms first and then my constant at the end. And so 6t minus 2x, and 3 plus 4 is 7. And you are now finished. Yes, that's a lot of work. Okay, anyway, that finishes example 2. In this next example, we are going to solve quadratic equations by factoring. Obviously, if we're going to solve by factoring, our quadratics need to be factorable. So that's the first thing that you need to check when you're working on these. Now, the second thing that's important, you need to be sure that your quadratics are in this form, ax squared plus bx plus c equals 0. Okay? Now, remember from section 4.1 when we were solving our quadratic equations by graphing, we were actually going to graph the corresponding function. So here's our corresponding function for this equation, ax squared plus bx plus c equals y. It's really important that your equation is equal to 0. In other words, it's really important that you replace y with 0. Okay, so you want to make it equal to 0. And why is that? because what we are really looking for are our x-intercepts, and x-intercepts only happen when y is equal to 0. So if you think back to 4.1, when you had two x-intercepts, you had two roots, and therefore two solutions. When you had one x-intercept, you had one root and therefore one solution. And when you had 0 x-intercepts, you had no real roots and therefore no solution. Okay, so this format is very important, and all of our questions are already written like that, but if they're not, you really need to rearrange your work so that it looks like this. Okay, so let's take a look at our first example. Notice that your coefficient on your x squared is 1. Okay, so that means no GCF. So we're going to start and factor right away. Okay, and don't forget to write equal to 0, because if you don't, you will lose marks. I will take marks off if you don't do that. Okay, you need to carry it on through. All right, so let's factor. We're going to factor our x squared into x and x. We're going to ask ourselves what two numbers, when we multiply, will give me 9 and add to give me 6. That would be 3 and 3. As long as they are both positive, you should check. 3 times 3 is 9. 3 plus 3 is 6, so that works. Now, in order for this quadratic statement to be true, this quadratic equation to be true, one of these factors has to be equal to 0 in order for this whole statement to be true. Okay, so I'm going to write that down. For the quadratic equation to equal 0, one of the factors must equal 0. Okay, now, but because we have two equal factors here, I only really need to set one of them equal to 0, okay, to find out when it's equal to 0, and I'll explain that in a moment. Okay, so I'm going to take my x plus 3, set it equal to 0, and solve for x. Okay, so I'm going to go x, move my positive 3 to the right, it becomes negative 3, and I find that x is equal to negative 3. So when I plug that in, okay, when I plug negative 3 into this x, for example, I'm going to get negative 3 plus 3, which is 0. Now this factor will be equal to 0, and then 0 times x plus 3 will give me 0, and so the statement will be true. Okay, now I don't have to go and repeat the process by setting my second x plus 3 factor equal to 0, because it's the same as this one. All right. Okay, now with this one here, notice we have one solution. Think back to our graph. When you had one solution, it meant you had one x-intercept. Okay, so when you have two equal roots here, okay, or two equal factors, what it means is we have two equal roots. I know it sounds kind of funny, but that's the way we would say it. And when you have two equal roots, you have only one x-intercept, or one solution. Okay, so two equal roots means one x-intercept. Okay, and actually maybe I can lead this in by saying two equal factors mean two equal roots, which means one x-intercept. Okay, now you've been asked to verify, so let's do that. We want to check that our negative 3 does indeed work, so we're going to plug it into the original equation. Remember, when you verify, always back into the original equation. So I'm going to go negative 3 squared plus 6 times negative 3 plus 9 equals 0. So 9 minus 18 plus 9 equals 0. So yes, my left side equals my right side. Okay, and so I know that my solution of x equals negative 3 is correct. Okay, so I solved correctly. Okay, on your next example, once again, a is 1, so there's no GCF. So we can start by factoring right away. What factors of negative 21 will give me 4? You should get positive 7 and negative 3. Check that it's right. 7 times negative 3 is negative 21. 7 plus negative 3 is positive 4, so you know you are correct. Okay, remember, for the quadratic equation to equal 0, one of the factors must equal 0. So we need to find out when each one of these factors is equal to 0. Okay, so I'm going to go x plus 7 equals 0, x minus 3 equals 0. Solve for x. Bring your positive 7 to the right, it becomes negative 7. Bring your negative 3 to the right, it becomes positive 3. And so notice that you've got two different roots here. When you graph that, that means you're going to have two x-intercepts. Okay, so let's check our answer. We've got 2, right? We've got x is negative 7 and x is 3, so we need to check both of them. Always back into the original equation. So negative 7 squared plus 4 times negative 7 minus 21 equals 0. So 49 minus 28. Minus 28 minus 21 equals 0. So yes, 0 is equal to 0. Substitute in 3. 3 squared plus 4 times 3 minus 21 equals 0. So 9 plus 12 minus 21 equals 0. So yes, 0 equals 0. So you know that you are correct on the positive 3. So your solutions are negative 7 and positive 3. Okay, next example. A is not a 1, it's a 2. Check if you have a GCF. No, we don't. There's no common factor for 2, 9, and 5 other than 1. So I'm going to use my organizer, okay? And I will set up my brackets here. Don't forget to put equals 0. Okay, there's only one way that I can factor the 2, 2 and 1. There's only one way to factor the 5, 5 and 1. I need to get 9 after I do my cross multiply, right? So I'm going to put my 5 here because I know that 2 times 5 is going to give me 10. That's pretty close to 9, right? And I'm going to put my 1 here. And so that gives me 1 times 1 is 1, and 2 times 5 is 10. I need negative 9. That means that my 10 should be negative and my 1 should be positive. So this will be plus, this will be minus. Remember, top row first bracket, bottom row second bracket. Okay, so I'm going to get 2x plus 1 and x minus 5. All right, set each of my factors equal to 0 and solve for x. Okay, check our answers. Remember, always substitute back into the original equation. So this is going to give me 0.5 plus 4.5 minus 5, and so 0 equals 0, so that one works. Substitute in the 5, and 25, so that's 50 minus 45 minus 5 equals 0, so 0 equals 0, so you know you are correct on that one. Okay, now our last question appears not to be in the form of ax squared plus bx plus c equals 0, but it is. It just means that your b is 0, okay? So we have a situation here where b is 0, so there is no bx term. Okay? So really the form that you have then is y equals ax squared plus c. Okay? So two ways you can approach this. You can approach it by factoring. Okay, it's a difference of squares. So when you factor that, square root your x squared, square root your 16, one bracket is plus, one is minus. Set both factors equal to 0 and solve for x. Okay, that's one way. An easier way, when you don't have a bx term, you can isolate your variable. So I'm going to move the negative 16 over to the right. It becomes positive. I'm going to square root both sides. The only place where I think you can make a mistake is that you might forget to put plus and minus in front of the square root of 16, which is 4. Okay? And the reason for that, when you have a situation like x squared equals 16, it's not specified whether you want a positive square root or a negative square root, so you have to go with both of them. Okay? And notice that it does correspond to the answer that we have when we factored. When we factored, you got negative 4 and 4. So if you feel that you might forget to put plus and minus, the 4 in this case, then factor. You will always get it right then. Okay? All right, and I'm not going to check this one here because we're running out of room, and what I really want to do is just to quickly discuss what does it look like when there are no real roots, like algebraically, what does that look like? Okay, so I'm just going to make myself some room here. So what does it look like when there are no real roots? Okay, now you know what that looks like graphically. You know that your quadratic, your parabola, is not going to cross over your x-axis, okay? So you're not going to have any x-intercepts. So how does that look algebraically? Well, I'm going to take this question D, and I'm just going to rewrite it so that instead of having negative 16, I'm going to have positive 16. So I'm going to write x squared plus 16 equals 0. I'm going to use my second method here, okay? So I'm going to isolate my x squared. My 16 goes to the other side. It becomes negative 16. And then I'm going to square root both sides. And I'm going to get plus and minus the square root of negative 16. Now, when you try to find the negative square root on your calculator, you're going to find that your calculator is going to read error, okay? And that's because you can't square root a negative number. In other words, the square root of a negative number is undefined. And therefore, I'm running out of room, are no real roots. Okay? In other words, no x-intercepts. Okay, so this concludes our discussion for example 3. So our last example for this section is for you to write and solve a quadratic equation. The length of an outdoor lacrosse field is 10 meters less than twice the width. The area of the field is 6,600 meters squared. Determine the dimensions of an outdoor lacrosse field. So when I'm working on these kinds of problems, I like to draw a diagram. And so I'm going to draw my lacrosse field. Now I know that the length of my lacrosse field is 10 meters less than twice the width. So I have to think, how would I write that? 10 meters less than twice the width. so that might look like 2x minus 10, right? 10 meters less than twice the width. And so that means that my width will be x. So you should write let statements. We're going to let x be the width and let 2x minus 10 be the length. Okay, now it's really important that you write your let statements using one variable for now. Okay, when we get into our unit where we will solve systems of equations, then you can use two. Okay, but for these questions, write let statements using one variable. Okay? All right. So we have expressed our length and our width as x and 2x minus 10. The other part of the question that's important and important information that they give us is that the area of the lacrosse field is 6,600 meters squared. Because they've given us area, that's a pretty good indicator on how we're going to solve for x. I have a length, I have a width, I know the area. I'm going to use the area formula for a rectangle. Okay, so area is length times width. Now, I already know that the area is 6,600. I know that my width is x, and I know that my length is 2x minus 10. So I'm going to substitute, okay? So the 6,600 goes in for A, my x is going to go in for W, and my 2x minus 10 is going to go in for L. Okay, so I'm going to get 6,600 equals 2x minus 10 times x. I want to simplify what I can, so I'm going to distribute. And I want to write this, oh yeah, okay, just distribute. So 2x squared minus 10x. Now I need my equation to be in the form of ax squared plus bx plus c equals 0. In other words, this has to equal 0. So I need to move my 6,600 over to the right. I'm going to put 0 here, and when I move my 6,600 to the right, it becomes negative. So do I have a GCF? Yes, I do. I have a GCF, which is 2. So I'm going to factor it out. Okay. And that's because I can use factoring to solve, right? So I get x squared minus 5x minus 3,300. And you can factor this. So what two numbers multiply to give me 3,300 and add to give me 5? That would be 60 and 55, as long as the 60 is negative and the 55 is positive. So why am I using inspection? Because my a in front of my x squared term is a 1. Okay, so check if this is right. Is negative 60 times positive 55 negative 3,300? Yes, it is. Is negative 60 plus 55 negative 5? Yes, it is. Okay, so we are going to solve for x now. So we want to set each of our factors equal to 0. So I'm going to go x minus 60 equals 0, and I get that x equals 60, and x plus 55 equals 0, and I get that x equals negative 55. And can we have a negative dimension? In other words, can our width be a negative number? No. So we are going to reject the negative 55. Okay, so that one's out. We keep the 60, and we need to find our length and our width because we've been asked to determine the dimensions of the outdoor lacrosse field. Okay, so we know according to our let statements that x is equal to the width, and so our width is 60. We know, according to our let statements, that 2x minus 10 is equal to the length. And so 2 times 60 minus 10, which is 120 minus 10, which is equal to 110, is the length. Okay, let's check if this is right. In other words, if I go length times width, do I get 6,600? Okay, so 60 times 110, that gives me 6,600. So am I right? Yes, I am. My left side equals my right side. So now I can write my sentence. The dimensions of the lacrosse field are 60 meters by 110 meters. Okay, so one last thing before I finish this video, I just want to show you a little bit of a shortcut when you're solving. Notice that in this factor, your 60 reads minus 60, in other words, negative 60. And when you solve and get your answer, you notice that your 60 is positive. Notice that your 55 here is positive 55, but when you went to solve for it, you got negative 55. So notice that your signs are opposite. So inside the bracket, if you have a negative number, when you solve, it will be positive. And if you have a positive number inside the bracket, when you go to solve it, it will be negative. And if we go back up to our previous examples, you'll see the same thing. Notice that you've got positive 3, and your answer is negative 3. You have positive 7, your answer is negative 7. You have negative 3, your answer is positive 3. You have a positive 1 here. When you solved, you got negative 1/2. Here you have negative 5. When you solve, you get 5. Positive 5, right? And over here, you've got positive 4. So when you solve, you get negative 4. And here you have negative 4. When you solve, you get positive 4. So you know, if you want, you can skip the step that reads x plus 3 equals 0, or x plus 7 equals 0, and x minus 3 equals 0, and just go straight from this step to your answer if you like. Okay, so that ends our discussion on 4.2, solving quadratic equations by factoring. Now, I'm going to do one more short video on another application problem that's a little more difficult than the one we just did. You don't have to watch it if you don't want to, but you can if you want to. I'll just call it example 5, and it'll be entirely up to you. So here is my example 5 that I was telling you about. It's quite a bit different from the lacrosse field question that you did. So let's tackle this together. So the area of a square is tripled. Okay, that's important. The area of the square is tripled by adding 10 centimeters to one dimension and 12 centimeters to the other. And you've been asked to determine the side length of the square. Okay, so here's our square. We don't know what the side length of that is, so I'm going to call it x. Okay, so I'm going to let x be the side length. Okay, I probably should put of the square. Now, we're going to add 10 centimeters to one dimension. So I'm going to add 10 centimeters to this dimension. Okay, so I'm going to add plus, right? And I'm going to add 12 centimeters to the other dimension. So I'm going to add 12. Okay, so notice that you now have a rectangle, and one side of your rectangle is x plus 12, and the other side of your rectangle is x plus 10. Okay. Now, I told you earlier that this information was important. The area of the square is tripled. So we probably want to know what the original area is so that we can triple it, okay? So the area of the square is, and that, you know, the original shape, okay, would be x times x, right? Length times width, which is x squared, okay? Now, if I want to triple the area, right, then I would want to go 3 times x squared, and I would get 3x squared, okay? Now, for a rectangle area's length times width, I know that one of my side lengths is x plus 10, and I know the other side length is x plus 12. And because this is going to triple my area, I'm going to put in 3x squared. Okay? And so now you're going to expand on the right, so you're going to FOIL. And you're going to get x squared plus 12x plus 10x plus 120. And I'm going to move everything to the left. Okay, and I'm going to do that. I know that seems like a lot of work, but I don't want to have a negative x squared, so I'm going to make this side equal to 0. When I bring my x squared over to the left, it becomes negative. I'm going to have 3x squared minus x squared, which is 2x squared. I'm going to combine my 12x plus my 10x. That gives me 22x, and I'm going to bring that to the other side. It becomes negative. And then I'm going to bring my 120 over to the other side, and it becomes negative 120. And I'm going to solve by factoring. Do I have a GCF? Yes, I do. It's 2. So that leaves me with 2 times x squared minus 11x minus 60. I can factor by inspection. The coefficient in front of my x squared is a 1, so I'm going to start by writing 2 brackets, sets of brackets, and placing an x in the front of each. So what 2 numbers will multiply to give me 60 but add to give me 11? That would be 15 and 4. I want negative 11, so my 15 will be negative and my 4 will be positive. Check if you're right. Negative 15 times 4 is negative 60, and negative 15 plus 4 is negative 11. You are right. Remember the little shortcut I was telling you? If I want to solve for x, I just pick opposite sign of the number inside the bracket. So x is equal to 15. And x is equal to negative 4. I reject the negative number. I stick with the 15. And I can check to see if that answer is correct. Okay. So let's check it out. So my original square would be x by x. So in other words, my area would be 15 times 15, right? Which is 225. For this diagram, for my rectangle, okay, if I add 15 to 10, I get 25 for this side. And if I add 15 to the 12, oops, I get 15 plus 12, I get 27, right? And then I want to check, well, first I want to find the area. Okay, so I want to go 25 times 27. And that gives me 675. So what I want to check is, if I take my original area and times it by 3, okay, so if I go 3 times 225, will I get 675? And you do. So left side equals right side, so you know you're correct. Okay, so the side length of the square is 15, and we're dealing with centimeters here? Yeah, centimeters. And you're done. So that ends example 5.